Okay, today we're going to learn about chapter 3, system of equations. Okay, the first one is 3.1, that is equation of three variables. But before that, let's do a revision on system of equation with two variables. Alright, so I gave you two examples here. The first example, 2x plus 3y equals 6 and x plus 2y equals 5. So how to solve this simultaneous linear equation? Okay, you have two choices. One is substitution, the other one is elimination method. So I'm going to show you elimination method. So in this case, I'm going to eliminate x variables because y variables is a bit hard. It involves 3 and 2, the coefficient for y. So you want to eliminate y, that means we have to multiply 2 here for equation number 1 and 3 equation number 2. So it's a bit troublesome. So let's get rid of the x. Just before that, we have to multiply 2 for this equation number 2. So we'll get 2x and 4y equals to 10. Why we have to multiply 2 here? Okay, so in order for us to eliminate x, we must make sure the coefficient for x is the same, right? So in this case, is the coefficient of x is already equal, right? Then we have to look at the symbol. So these two are positive, therefore we minus. If this is positive, this is negative, then we plus, right? So we minus. So when you minus 2x plus 3y equals 6 minus 2x minus 4y equals 10, so 2x minus 2x equals to 0, 3y minus 4y equals to negative y, and then 6 minus 10 equals to negative 4. Therefore, we have y equals to 4, right? Then you can get the value of x by substituting the y equal to 4 into the equation number 2, right? Equation number 2 is x plus 2y equals to 5, right? So when you substitute in, you get x plus 2 times 4 equals to 5. You get x plus 8 equals to 5, and hence you get x equal to negative 3, right? So this is example 1. So let's see the example 2. Example 2, we have x plus y equal to 2 and x minus y equals to 4. So in this case, we no need to multiply any numbers here or constant here because both x and both y has the same coefficient. So for example 1, I already eliminate x, right? So now I'm going to eliminate y, right? So to eliminate y, you'll see the symbol first. Coefficient we know already is 1 and 1. So the symbol positive and negative. So it's opposite or different symbol. Therefore, we add these two equations together, right? Like this. So you'll get x plus x equal to 2x and y plus minus y will be y minus y equal to 0, and then 2 plus 4 equals to 6. So you'll get 2x equal to 6, x equal to 3. And same goes for equation for example 1, right? So we'll substitute x equal to 3 into equation number 1 or equation number 2, right? So I will choose equation number 1. So your x plus y equal to 2. So 3 become 3 plus y equal to 2. 2y, right? 3, you move it to the right hand side. 2 minus 3, you get negative 1. So our answer for this equation, this simultaneous linear equation will be x equal to 3, y equals to negative 1. All right? Okay, let's see how to describe a linear equation in three variables. Okay, so the general form of linear equation in three variables can be written as ax plus by plus cz equals 0, where a, b, and c are not equal to 0. Okay, let's refresh back for system linear equation with two variables. Alright, so from the previous examples, we have 2x plus 3y equals 6, x plus 2y equals 5. Okay, there is a pair of equation here. Right, same goes to the x plus y equal to 2 and x minus y equal to 4. Also a pair here. But for system linear equation with three variables, we have three linear equation. For example, like this: x plus 4y plus 3z equal to 2, 3x minus 3y minus 2z equal to 4, x minus y minus z equals to 4. Okay, this is only an example. Alright, so how you describe a system of linear equation with three variables with ax plus by plus cz equal to 0. Right? The second part is the system linear of equation in three variables has three axes, namely x-axis, y-axis, and z-axis. Okay, this is graph. How to represent in the graph form. All three linear equations form a plane on each axis. Okay, so this linear equation will form a plane. Then every linear equation in two variable forms a straight line on each axis. Okay, meaning that x plus 4y equal to 2 will form a straight line, 4y plus 3z will form a straight line, and then x plus 3z will form a straight line. So there are three straight lines. You combine it, it will become a plane. Alright, later on we will see how to sketch the graph. Okay, now we want to sketch linear equation with three variables, but before that let's do revise on how to sketch linear equation with two variables. Okay, so for example, we have x plus y equals to 2, right? So what we need to do is to find the y-intercept, the x-intercept. So in order to find x-intercept, let y equal to 0. So when y equal to 0, x equal to 2, right? So very clear, right? So if I cover up like this, that means x equal to 2. When I want to find y-intercept, then x equals to 0. So you have x equal to 0, y equals to 2. Therefore, we start to sketch the graph. Draw a two straight line. Okay, arrow going here is x-intercept, horizontal is x-intercept, then vertical is y-intercept, and this is 0, the origin. So this part will be positive, and then this part also positive. So we have y equal to 2 and x equal to 2. So we put 2, let's say this is 2 and this is 2. And then you just join the 2 points together. Voila, this is your graph for x plus y equals to 2. Now let's see how to sketch linear equation with three variables. Alright, so for example, I have graphing a linear equation in three variables. The example is 3x plus 2y plus 4z equal to 12. Same goes with the equation with two variables. We find all the intercepts first. That means x-intercept, y-intercept, and z-intercept. Right? So for three variables, if I want to find z-intercept, I have to let x and y become 0. Okay, let's say x equal to 0, y equals 0. That means I cover up these two, then y 4z equals to 12, right? And then z will be 3. 4 times 3 is 12, right? So z is 3. Then I can go to find x-intercept. So x-intercept, I have to cover up y and z. Okay, y and z. I cover up these two, z, this one and this one. Then you can get 3x equals to 12. So you get x equals to 4. And then I want to find y-intercept. I cover up the x and the z. So I get 2y equals to 12. Then you have y equal to 6. So you get x-intercept, 4, y-intercept, 6. Now we can sketch the graph for the equation of three variables is a bit different from linear equation with two variables because we have three axes. Okay, so how we sketch, it's like this. So this is y-intercept, z-intercept, x-intercept. So I need to explain here. So for y-axis, the right side is positive. This part is positive. For z-intercept, z-axis, the upper part will be positive. But for the x-axis here, okay, this part will be positive and this part is negative, right? So after you have sketched the axes, then we can plot the points. The first point is z equals to 3, right? So z equals to 3, so we estimate here is 3, right? Okay, and then y is 6, y-intercept is 6 here, and then x-intercept is 4 here, right? So remember, this part x is positive. Okay, maybe some of you will be confused, why not this part, right? If you turn up here, become x-intercept, this one x-intercept, this one z-intercept, then you can see here clearly the upper part is positive, right? So, and then after you plot the three intercept, then you join up together with a straight line. 3 to 6, 6 to 4, and 4 to 3, we'll get a plane, right? So you join up, you get a plane like this. So this is how you sketch linear equation in three variables. All right. Okay, so now we're going to see how many solutions are there for system of three linear equations, right? So there are three types of solutions. Okay, for you can see here for these examples. Okay, so x plus 2y minus 3z. Okay, x plus 2y minus 3z equal to negative 3, and 2x minus 5y plus 4z equal to 13, and 5x plus 4y minus z equals to 5. If you solve it, you'll get a solution like this, x, y, and z, right? So the solution is 2, negative 1, and 1. So this system above has only one solution. Right, doesn't mean that all system of three linear equation will have one solution. Okay, let's look at others. Okay, the graph of a linear equation in three variable is a plane in three-dimensional space. The graph of the three such equations that form a system are three planes whose intersection determines the number of solutions of the system, as shown in the diagram below. So if only one solution, you'll see clearly here, the three planes here, the red plane, the green planes, and the blue planes will intersect at one point. Okay, exactly one solution. Alright, then the second diagram will show you the planes that intersect in a line or are the same plane. You can see here the blue planes, the green and the red planes intersect at one straight line. Okay, and this one will be infinite many solution. That means the solution, there is a lot of points here. Okay, you can see here there's in this diagram is only shown to you is a small part of it. So it can be extended into up and down, right? This part. Okay, so these are the two solutions. There's another solution. Okay, another solution is this. This has no solution at all. Okay, you can see here the first diagram here. Okay, the blue and green only intersect at a line. Red and green also intersect at a line, and red and blue intersect at a line, but the three lines are not intersecting each other, so therefore there is no solution, meaning that there is no intersection between the three planes. Okay, the second diagram you can see here quite clear also. The red planes intersect the green and blue at two lines, okay, but not a point. And then the third one will be the three planes are not intersecting each other, they are parallel. So here is very clear that there is no solution or no intersection between the three planes or the three equations. All right.